Our last lesson for slope is slope day 4. We're going to do some more practice and then also throw in there a plot twist. So just as a reminder, slope is defined as the letter M. When we look at slope on a graph, we can talk about it as rise over run. And when we're looking at it from points or even on a graph, we can call it delta y over delta x. And then we would also include that if we have points, we can do y2 minus y1 over x2 minus x1. In right here with this Mr. Slope guy, we do have the reminder of our types of slope that we can have. So a positive slope would look like it's going upward from left to right. A negative slope will look like it's going downward. Our undefined slope is right here. Undefined slope would happen if you have a number and then the 0 would be on the bottom then. So there would be no run, it would just be going up and down. So you have this vertical line here and that's called undefined. We can't divide by 0 in math, so that's why we call that one undefined. His mouth going across here, this is 0 slope, which means you would have a 0 in your numerator and then a number down here in your denominator. So just to real quick refresh that, we're going to plot some points here. So we have the 0.51 and then we have the 0.24. And if I connect those two together with a line, and then I extend that line just a tiny little bit, that was not a line, we're going to actually see a line that's going downward from left to right. So we would call this a negative slope then for this line. When we actually calculated the number, it would have a negative in it. For our next one, we're going to do negative 2, 3, and negative 2, negative 5. Note that this line is one of these vertical lines, so that is the nose part, which would mean that this one is undefined. For our next example, we have negative 1, 2, and also the point negative 4, 0. As I go from left to right on this one, my graph is going toward upward, so this would be a positive slope. Go ahead, plot the 2 points in number 6 and tell me if it's positive, negative, 0, or undefined. So we have negative 3, negative 4 down over here, and 5, negative 4, which would be right over here. Since this one is a horizontal line, there is no rise, but there is run. We would call this a slope of 0. You can also just write the number 0 as well. In this next section, it says to draw a line through the point for the given type of slope. So we have this point right here, and we want to show a positive slope. So positive would need to move upward. So I'm going to go ahead and just draw my line through that point then. For a 0 slope, we would need to go a horizontal line. So I could go just like this across here. And for the last one, a negative slope would mean that as I look from left to right, I'm going downwards. So I'm going to actually start and go backwards here. So that would be an example of a negative slope then. On our next page in our notes packet, we're just going to practice using the formula, finding our slope between these two values. So for the first one, my slope is going to be a negative 8 minus a negative 2 for my changes in y's, and a 4 minus 5 for my changes in x's. Following my integer rules, I'm going to have negative 6 over negative 1, which will give me a positive 6 for my slope. In the second example, I'm going to do 15 minus 10 over 5 minus 5. 15 minus 10 will give me 5. 5 minus 5 is 0. Since I can't have a 0 in my denominator, we actually call this slope undefined then. In the next two examples, in the first one, my slope, I'm going to be doing 5 minus 5, and then I'm going to do 10 minus 6. 5 minus 5 is 0, and 10 minus 6 is 4. Since we have a 0 in the denominator, this is just a slope of 0. For the last one, 8 minus 7 over 6 minus 3. 8 minus 7 will give me a 1, and 6 minus 3 will give me a 3. So that would be considered a positive slope. Little plot twist that will throw your direction is, can you find the missing coordinate? So remember that you have y2 minus y1 over x2 minus x1 is equal to your slope then. So what you're going to do is we're going to set up and simplify and then solve this like a proportion here. So for my first example, my slope is 1. So I'm going to say 1 equals, I have 8 minus h over 4 minus 1. I'm going to reduce this and I'm going to put this 1 over 1. So I'm going to have 1 over 1 equals 8 minus h over 3. I'm going to go ahead and solve this like a proportion. 3 times 1 is 3. 1 times 8 minus h is 8 minus h. So I'm going to subtract my 8 on both sides. I'm going to get negative 5 equals negative h. Dividing through by that negative 1, h is equal to a 5. So my h value that's missing here would be a 5. In my next one, my slope is negative 1/2, I need to take that negative sign and I either need to move it up with the 1 or down with the 2. So I'm just going to move it up with the 1. And I'm going to have negative 10 minus a negative 7 over 3 minus s. I'm going to simplify this. So I have negative 1 over 2 equals, this becomes plus a positive, so I get negative 3 over 3 minus s. So negative 1 times 3 minus s is equal to a negative 6. I'm going to use my shortcut and divide by negative 1. So I get 3 minus s equals 6. And I'm going to subtract 3 on both sides, leaving me with negative s equals 3. Remember, this is a negative 1, so I'm going to divide by negative 1 on both sides, and I get s is equal to negative 3 then, is my missing value for that coordinate.